Hello and welcome to my science tutorials. In today's video, we are going to be looking at the application of differentiation, that is, how to find the gradient, tangent, and normal to a curve. Before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's go ahead. So first of all, we want to start by finding the gradient to a curve, or how to find the gradient to a curve. Now, given that we have a point P is equal to what? X1, Y1 on a curve, and we want to find the gradient on that particular curve. All we need to do is to what? Differentiate the function that gives us that curve. We differentiate the function and then we input the value of what? X into the equation to get our gradient. What do I mean by this? Let's have a look at an example. Alright, so given that we have f of x is equal to what? S squared plus 3 all square. We have to find the gradient of the curve at the point x is equal to what? Half. So first of all, we need to differentiate the function we have over here. Now this function f of x can be rewritten as y is equal to s squared plus 3 all square. Now we say let u be equal to what we have in the bracket, s squared plus 3. Now we differentiate. Now from here we can say what? Y is equal to what? U squared, because we say let u be what is in the bracket over here. So if we say y is equal to u squared, that makes sense. So we go ahead and differentiate this equation and this before we can be able to get our differential equation. So if we differentiate u, we have what? Du dx is equal to, if we differentiate s squared plus 3, we are going to get 2x. Now if we differentiate y, we are going to get dy du, and then we are going to get what? 2u from here. Okay, so it means from here, if you want to get our dy dx, it means we need to multiply this du dx by what? Dy du. So you can see from here, du will cancel du, so we have dy over dx, which is just what we have over here. So we have here dy dx is equal to, then we have this to be 2x multiplied by what? 2u. Okay, so this is equal to what? 4xu. But we know that what? U is equal to what? S squared plus 3. So it means our dy dx is equal to 4x into bracket the u, s squared plus 3. So from here we just simplify what we have in the bracket, and then we get the differentiation of this function. So if you multiply that, we get what? 4s cubed plus this will give us what? 12x. So this is what we get after we differentiate this function. Now the question is telling us to find the gradient at what? The point x is equal to half. So it means all we need to do is what? We say f of x, that is f prime of x, at the point x is equal to half is given to us by what? The dy ds can be rewritten as what? F prime of x. So we have what? F prime of x, or dy ds, is equal to what? 4 into bracket half cube plus what? 12 into bracket half. Okay, so this will give us, if we do everything over here, we are going to get half over here plus this will give us 6. So it means our answer for the gradient, okay, for this particular example is 6.5 or 6.5 dy dx. It doesn't matter whether you use dy dx or f prime of x, it means the differential of the function that you are given. So this is how we go about finding the gradient to a curve. So this is just one example. Let's have a look at another example. So example number 2, we have what? Y is equal to x minus 3 s squared plus 2 at the point at the point what s is equal to 3. So we have to find the gradient to the curve at the point s is equal to 3. So we go ahead and then differentiate the function that we have, and then we input the value of x inside. So let's go ahead. Now if we have this sort of equation to differentiate, first of all we say what, let the first term be u, okay, then we let v be the second term, s squared plus what, 2. Now the formula that we use to find the differentiation of this is what we call what, the product rule. Okay, and then the product rule will give us what, v du dx plus u dv dx. So this is what, the f prime, which is this is dy dx, is equal to this. So first of all, it means we need to differentiate our u, which is what we have over here, and then multiply it with v, and then we hold v, and then we differentiate y, and then we multiply it. So let's go ahead and do that. So if we differentiate u, which is du dx, we are going to get what? If we differentiate x minus 3, we will just get what? 1. Now if we differentiate v with respect to x, this is what, s squared plus 2. So if we differentiate, we are going to get what? 2x. So it means our dy dx is equal to what? The v is what? S squared plus 2. Then du dx, which is what? 1, plus u. Our u is what? X minus 3. Then our dv dx is what? 2x. So we expand the bracket, and then we get our answer for this. So we have what? S squared plus 2 plus this will give us 2s squared minus what? 6x. So from there we further say what? Dy dx is equal to what? We have here s squared, so we have 3s squared minus 6x plus 2. So this is what we get if we differentiate this function. Now it means the gradient at what? The point s is equal to 3 will be given to us by what? Substituting the value of x into what we have over here. So we have dy dx is equal to 3 into bracket what? 3 squared minus 6x, which the x over here is 3, plus 2. So we just simplify. So we have this will give us what? 27 minus this is what? 18, then plus 2. So our final answer over here, this is going to be 29 minus 18. 29, if we add this and this, minus 18. So we are going to get what? 11 as what? The gradient to the curve for this example. So this is how we just simply go ahead and find the gradient to the curve of a particular function. Now let's move ahead to go and see how to find what? The tangent and then the normal to a curve. This is to a curve. Okay, now for us to find the normal or the tangent to a curve, we need a particular formula to use. Now the tangent to a curve is given by the formula. The tangent to a curve is given by what? Y minus y1 is equal to what? M into bracket x minus x1, where our m is what? The gradient to the curve. The gradient to the curve. And then what? Our y1 and then x1 are the points at P, or the coordinate where the tangent touches the curve. Those coordinates are what we call the x1 and then the y1. Now the normal to the curve, on the other hand, is given by what? Y minus y1 equals negative 1 over m into bracket x minus x1. So this is the formula that we use to find the normal to the curve, and this is what we use to find what? The tangent to the curve. Actually, the diagrams look like this. So we have a curve, and then we have, this is our normal, and then this is our tangent. Okay, this is not drawn to scale, so this is our tangent line, and then this is our normal. Okay, so we have y is equal to what? F of x, that is the function that is giving us the curve, and then our normal makes an angle of what? 90 degrees to the curve. Now, so this is this is the point P, where we have our x and then the y coordinates. So we have x1, y1. These are the points. The point at P over here, they are the points that we use to substitute in place of y1 and then x1 over here to get our tangent and then the normal to the curve. So let's have a look at an example. So we have here, given that y is equal to x cubed minus 4x squared plus 5x minus 2, find dy dx. Q is the point what on the curve where s is equal to 3. I calculate the y coordinate of Q. I calculate the gradient at Q. I the equation of the tangent at Q. IV equation of the normal at Q. And then find the values of x for which the curve has what? The gradient of 5. So let's go ahead. First things first. So we have our equation, y is equal to x cubed minus 4x squared plus 5x minus 2. We are being told to find what? Dy dx. So we differentiate this. Dy dx will give us what? 3x squared from here minus what? 8x from here plus what? 5. So this is what we get if we differentiate this over here. Now let's tackle the I aspect of the question. The I aspect is telling us to calculate the y coordinate at Q. For us to find the y coordinate at Q, we need to use the normal equation that we have over here to find the y coordinate, where the x1 coordinate is what? 3 over here. So all we gotta do is what? Say y is equal to what? Our, this is x cubed minus 4x squared plus 5x minus 2. So we write over here y is equal to what? S is equal to 3. So we write 3 cubed minus 4 into bracket 3 all squared plus 5 into bracket 3 minus 2. This is 3. Sorry about that. Okay, so it means this is equal to what? This is 27 minus this is 36 plus this is what? 15. This is minus 2. So if we input everything here into the calculator, we will get our y to be 4. So it means what? We have at the point Q, our what? X1, Y1 are, as I'm going to write over here. So we have over here our x is what? 3, our y is what? 4. So we have the point Q on the curve where the normal and then the tangent met before we have been asked to find everything over here. So the I aspect of the question, we have to find what? The gradient at what? Q. So the gradient, as you know, we just substitute the value of what? X into what? The differential equation. So we have dy dx is equal to what? 3x squared minus 8x plus 5. But we have what? Our x value to be what? 3. So we write 3 squared minus 8 3 plus 5. So our gradient, let me use m. Okay, m, which is the gradient over here, is going to be what? This is 27 minus this is 24 plus 5. So our gradient m is equal to what? 32, that is this plus this, minus 24, and then our m is what? 8. So it means our what? Our gradient for this particular example is 8. So now that we have our gradient and then we have our coordinate on the curve, let's go ahead and find what? The tangent to the curve, the normal to the curve, and then we tackle the last aspect of the question. So I, the tangent. Now remember I said the equation for finding the tangent is what? Y minus y1 equals what? M into bracket x minus x1. Now we have the point Q to be what? Let's go back and see. We have 3 and 4. So 3, 4. And then our gradient M is equal to what? Let's go back. We have 8. Alright. 8. So we just go ahead and substitute over here. So we have y minus our y1 is what? 4 equals what? 8 into bracket x minus x1 is what? 3. So we simplify this. We have y minus 4 is equal to what? This is 8x minus what? 24. So it means we have y minus 4 minus 8x plus 24 is equal to 0. So it means we have what? Y minus 8x negative 4 plus 24, this will give us 20, is equal to 0. So this is our what? Equation of the tangent to the curve. So let's move on. Our IV, the normal to the curve. The normal in this example will be what? Y minus y1 equals what? Negative 1 over m into bracket x minus what? x1. So we have what? The same thing. Y minus 4 is equal to negative 1 over 8 into bracket x minus what? x1. So the x1, sorry, over here will be 3. So let me, okay, 3. So I'll go ahead and multiply both sides by 8 so that we can get rid of the fraction over here. So 8 times this will give us what? 8y minus 4 times 8 will give us what? 32 is equal to 8 multiplied by all of this will give us negative 1 into bracket x minus what? 3. So let's divide this. We move on. We have what? 8y minus 32 is equal to negative x plus 3. So we have 8y minus 32 plus x. We brought this over here. Then minus 3 is equal to 0. So we have what? 8y. The s is what? Still here plus x. This is what? Minus 30 what? 5 is equal to what? 0. So this is our equation of the normal to the curve. So now let's look at the final aspect of the question. The final aspect is telling us, let's go back and see, we have to find the values of x for which the curve has the gradient of 5. So the gradient for the curve to have the gradient of 5, it means our m, which is what? Equivalent to what? The dy dx when we input the value of x over here, or the f prime of x over here is equal to what? 3x squared minus 8x plus 5. This is the differentiation that we had. This we had when we differentiated the equation that we are given. So it's just the same thing that I'm writing over here. Now they are telling us the gradient at this point is what? 5. So it means 5 is equal to what? 3x squared minus 8x plus 5. So we need to find the values of x at which the gradient is 5. So we just go ahead and simplify this. So we have 5 minus, we bring this 5 to the other side, then we have what? 3x squared minus what? 8x. So this is 0 is equal to what? 3x squared minus what? 8x. So what do? We look at this, then we factorize what we have over. So let me rewrite this. So we have 3x squared minus what? 8s is equal to 0. Let me just squeeze some space over here. So if we see over here, we can only factor s out, so we bring s out into bracket, then we have what? 3x left minus what? 8 is equal to 0. So it means s is either equal to 0 or 3s minus 8 is equal to 0. So which means we have 3s is equal to 8, and then what? We divide both sides by 3. Then we have our x is equal to what? 8 over 3. So the values of x for which the gradient m will be 5 okay, as I've written over here, will be what? S is either equal to 0 and S is equal to what? 8/3. So it means for us to get a gradient of 5, S has to be what? 0 or what? 8/3. So thank you so much for watching. This is how we solve this is how we calculate the gradient, tangent and normal to a curve. I hope this tutorial was useful. If you find it useful, please kindly consider subscribing, then pressing that notification button so that you don't miss any of our tutorial videos. Thank you so much for watching, and I will see you in the next video. Bye bye.